Greetings, Panthers. Dr. Augustine. Turns out I lied in the last video. The next video is not going to be about significant figures, but rather is going to be about units. This is going to be a really quick one. We're just going to talk about units, the importance of them, and then the difference between base units and derived units. And an example we'll give a derived unit is volume and density. So this is chapter 1.6 intro. And let's talk for a minute about base units, systems of units, etc. So there's two major systems of units out there. There's the English system, and we are very familiar with the English system here in the United States. We have things like miles, yards, Fahrenheit, gallons, etc. Okay, lots of different units, and they're all the ones that you are familiar with. And then we have the metric system. And that has things like meters, liters, Celsius, etc. Well, in science, we are going to use the metric system, and in fact, we use what's called the SI system, System International. I'm not French, so I'm not exactly sure how to pronounce that. But we use the SI system, which is based on the metric system, and pretty much all the measurements we're going to have in this class are going to be based on the metric system. Now, in this class, I do not expect you to know how many meters there are in a mile, for instance, or how many yards there are in a meter. I would give you all those conversion factors, but if you are given the conversion factor, you should know how to convert between them. So an important concept is the idea of a base unit, and the base unit tells us about something we're measuring. Let's say we're measuring time. The base unit would be seconds for time. If we're measuring distance, the base unit is meters. I'm going to write the whole thing out here, seconds. So we give it a symbol S. Meters, we give it a symbol M. Current would be amperes, etc. So each sort of fundamental quantity has a base unit associated with it, seconds, meters, amperes, and some things are a combination of those units. So for example, volume is not a base unit. You may be surprised to know that. We have a unit in the metric system for volume, and that unit is liters. But that is a derived unit, it's not a base unit. So why do we call that a derived unit? Well, the base unit is actually distance, meters. But you know the volume is the length times the width times the height. Okay, so if we take length times width times height, we end up with a new object which fills up some space, and now we can use a thing called volume for that. So let's just write this down on here. Let's say this is the length here. This is the width here. And this is the height here. So volume is equal to length times width times height. Or, in other words, if we're using the base units on this, it would be meters times meters times meters, or meters cubed. So a unit volume has a unit of length cubed. So any length cubed unit is actually a volume unit. So for example, suppose we weren't measuring this in meters, but we're actually measuring this in centimeters. Then we would have centimeters times centimeters times centimeters is equal to centimeters cubed. Or it could be in nanometers. Nanometers times nanometers times nanometers. Nanometers cubed. Okay, but here's the idea. Anytime you have a distance unit that's cubed, centimeters cubed, nanometers cubed, meters cubed, that is a measure of volume. So that's a derived unit. It comes from the base unit, which is distance, times distance, which gives us distance cubed. Another common derived unit is density. Density is an intrinsic property of a material. If you see something floating on top of the water, it tells you that the density of whatever that object is less than the density of water. If it sinks down to the bottom, the density is higher than the density of water. Water happens to have a density of 1.00 grams per centimeter cubed. So if you see a piece of wood floating on top of water, you know that the density must be less than 1.00 grams per centimeter cubed. If you throw something like a piece of metal in the water and it sinks down to the bottom, you know that the density must be higher than 1.00 times grams per centimeter cubed. Okay? So density is also a derived unit, and it is the mass over the volume. So the units on this would obviously be a mass unit of some sort divided by a volume unit. And a common one for objects is going to be grams per centimeter cubed. I should have mentioned for mass, grams is actually a base unit. But centimeter cubed is not the base unit. For distance, meters is the base unit. So these derived units don't have to be in terms of base units necessarily. Grams per centimeter cubed is a common unit that's used for the density of solid objects. If we were talking about the density of something like a gas, we might have grams per liter or grams per meter cubed or something like that. Much larger volume using the same mass. But anytime we have a mass unit divided by a volume unit, that is an indication that we have something that's related to density. All right, so let's take a look at a really easy problem. We're going to do way more density problems as the semester goes, but let's take a look at this one. Density of a solution has a mass of 13.5 grams and a volume of 15.8 milliliters. So milliliters is a unit of volume, so that would be equal to 0.854 grams per milliliter. A couple things to point out here. There are 3 significant figures in this number. That is the next video. 3 significant figures in this number. We mentioned in the first video that when you multiply or divide, the one with the least number of significant figures tells you what your answer should be. So our answer should have 3 significant figures. If you don't know how to count these yet, just check out the next video. Grams per milliliter is the unit on this. And you might be saying, well, wait a minute, that's different. Up here you said grams per centimeter cubed. And where's milliliters come into play? Milliliter is another unit of volume. So where does that come from? Well, if we take a look at this figure right here, this is showing that a 10 centimeter by 10 centimeter by 10 centimeter cube is each one of these little cubes would be 1 centimeter. So picture a centimeter is about the size of your thumbnail. So if we had a centimeter by a centimeter by a centimeter, that would be 1 centimeter cubed. And if we had a 10 by 10 by 10 of one of those, that is actually equal to 1 liter. That's the definition of 1 liter. So this whole thing right here is 1 liter. 10 centimeters by 10 centimeters by 10 centimeters. So a milliliter is a thousandth of a liter. So it turns out that 1 milliliter is equal to 1 centimeter cubed. So that little thing, that little object that's depicted right here, 1 centimeter cubed, that's actually equal to 1 milliliter. So we could redo this problem if we wanted to as 15.8 milliliters times 1 centimeter cubed for every 1 milliliter. Milliliters will cancel milliliters. It's the same number. So the final unit on this answer right here is grams per centimeter cubed. It would also be equal to 0.854 grams per centimeter cubed. All right, so either one of these would be acceptable answers. Now, of course, the way the problem is worded would dictate which unit you want to use. If it asks for grams per milliliter, you would do this. But typically, grams per centimeter cubed is a much more common expression. I should point out, this is something you should know. 1 centimeter equals 1 milliliter. 1 centimeter cubed equals 1 milliliter. That's a very common conversion. You should also know the density. That's a very common factor that you might want to know. I already mentioned you do not need to know the conversions between, like, let's say cups and milliliters or anything. You would be given those, or miles and kilometers or something. But these are two things you should have in mind. You should know what the density of pure water is, about 1 gram per centimeter cubed. And you also should know the conversion between milliliters and centimeters cubed. They are both the same thing. 1 centimeter cubed is 1 milliliter. Okay, so that's our quick video on units.